Okay, question 4. We've got a range of 0 to 2 pi and it's asked us to solve this equation. I'm guessing for most of you, you would have started by rewriting sec x as 1 over cos x. So let's do that method. Once we've written that down, we're probably going to want to bring that cos up. Now that's not particularly easy to solve. You've got to spot something, and you should always be on the lookout for double angle formulas used backwards. So that's when you've got, especially this one, the sine x cos x. Now we know that we know two things. We know the sine 2x, or hopefully you know, that sine 2x is equal to 2 sine x cos x. And we also know the cos ones. Cos of 2x is equal to 2 cos squared x minus 1, or 1 minus 2 sine squared x. That's no use to us here, but this should be ringing some bells, okay? If you see sine x times cos x, you should be thinking sine 2x. We've not got 2 sine x cos x, we've got 4 sine x cos x, so that is the same as 2 sine 2x. This we can now solve because we've just got a trig equation with one trig function in. A sine x, cos x, or a tan x we can deal with. So we're going to divide by 2. And we're going to inverse sine. Now when we inverse sine, that's going to tell us 2x, not just x. Inverse sine of a half is pi over 6. You need to be in radians for this, remember? Now, we need to be aware of how many solutions we're going to get, and even though this is 0 to pi over 2, we need to think about the fact that we've got 2 x's, so we need to extend the range of values from 0 to pi over 2 to 0 to pi. We need to double the range because there's double the amount of x's we're going to get. So pi over 2 becomes pi, so there will be 2 answers. There's going to be another one. We've got this one, we've got the pi over 6, but there's going to be another one here at 5 pi over 6. And then the last job is to just divide by 2 to get actually x, not 2x. So pi over 12 and 5 pi over 12. You can check each value. On these trig ones, it's worth checking each value actually works. You could substitute into each side of here and here and check that they give you the same answer for both values. It will be right for this one, but sometimes if you squared and then square rooted later, you sometimes get false answers. Okay, part 2, 5 part 2 is a really difficult question to spot what you're meant to do. We have done a section of work when things are written in this form. And that's when we turn them into r sine theta plus alpha, okay? Usually they tell you how to do this. They tell you, write it in the form r sine theta plus alpha, and everybody's happy. They've not told us to do it here, which has just made it extra difficult for us. We need to be ready to spot r sine theta plus alpha questions. Now, first thing to realise, or after we've spotted it, is to realise that's a minus. So actually we're going to want to do minuses in here. If you get the choice, go with sine and make the plus or minus match in your bracket. So we're saying that we know that r sine theta minus alpha is going to be the same as, going to be identical to 5 sine theta minus 5 cos theta. This is the double angle formula. So we can expand this, we can rewrite it. I'm just going to switch the way around I've written them. So sine of A minus B is sine A, so that's theta, cos B, so that's alpha, minus the other way around, so sine alpha cos theta. We can multiply the r in. And because this is an identity, the left hand side needs to equal the right hand side for all values of theta. So what we can now do is we can choose a value of theta to make this identity simplify down to hopefully allow us to work out r and something about theta as well. Oh, alpha, sorry. So the first value we're going to choose is 0, because sine of 0 is 0, and that's going to make this much easier to work with. Cos of 0 is also 1, so that now tells me that the left hand side when theta is equal to 0 is equal to minus 5. The right hand side we're going to have a 0 here, we're going to have a 1 here, so that's going to equal negative r sine alpha. The minuses cancel, so we've got 5 equals r sine alpha. Next value to choose is 90 degrees. Now notice we are in degrees for this question, even though we've just been in radians for part 1, they want us in degrees now. So you need to make sure you're keeping track of those kind of things as well. When theta is equal to 90, sine of 90 is 1, so we've got 5. Cos of 90 is 0 though, so we've just got 5 on the left hand side. On the right hand side, this is going to be 0 now because of the cos 90, but this is going to be r times 1 times cos alpha, so just r cos alpha. So we've got two things, we've got 5 equals r sine alpha and 5 equals cos sine alpha. We can write that sine alpha is equal to 5 divided by r, and we can say that cos alpha is equal to 5 divided by r as well. If we link that to a right angled triangle with alpha in here, this is my opposite and hypotenuse, so I'm going to have a 5 on the opposite and r on the hypotenuse, and so is this, so 5 on the adjacent, r is already on the hypotenuse, so it's an isosceles triangle. It's an isosceles triangle, that means that alpha is 45 degrees. It also means that we can use Pythagoras to work out r. So we can say that r squared is going to be 5 squared plus another 5 squared, which is 50, so r is root 50. All that means is that we can change this question that they've given us into, instead of writing the 5 sine alpha minus 5 cos alpha, or theta, sorry, we can write root 50 and then just sine theta plus, minus, wasn't it? Minus 45 degrees that we've worked out alpha to be. And we're going to set that equal to 2. Because they've set the equation equal to 2. So, now, this is the equation we're going to solve. We're going to divide by root 50. I'm going to inverse sine it. Which is 16.43. I'm going to need a couple of values. We need 0 to 360. But bear in mind that we're going to be adding 45 degrees on. That's actually not going to make any difference. That's not going to change the values that we give. They're still both going to be in the 0 to 360 range. So actually that's quite useful. So to get the other value here, I need to do 180 minus 16.43, which is 163.6. and then I can add 45 degrees onto both of those. So the larger one is 208.6, the smaller one is 61.4.